Hello and welcome to this Vivado Quick Take video where you will learn about using Vivado to debug at and around device startup. When a design is programmed into a device, there is a device startup sequence that occurs after the bitstream loading phase. You might be interested in debugging around events that occur at the startup phase. It is often too late to trigger around events in the startup sequence as part of your default debug setup. Trigger at Startup is a new feature introduced in Vivado 2014.1, and this feature can be used to pre-arm a debug core and trigger on events at device startup. We'll start with looking at the benefits of using the Trigger at Startup feature and situations where they can be used. We'll also look at the Vivado Trigger at Startup flow, which is used to create, pre-arm, and run a trigger at device startup. I'll then launch Vivado and show you how to set up and apply these startup trigger conditions and create a new bitstream. Finally, I'll also show you how to use these newly generated bitstreams to trigger on events at device startup using Vivado Hardware Manager. Every once in a while, we need to debug events that might occur around device startup. The device startup events could include MMCM PLL lock events, asserting the global write enable event, which allows the RAMs and the flip-flops to change state, and the event that activates the IOs. This feature can also be used to debug events close to device startup. Some common design-specific events around startup might include memory calibration start-end events, state machine start events whose execution starts right after the startup sequence, processor start execution event, and system coming out of reset event. The Vivado Hardware Manager can be used to create, pre-arm, and run the startup trigger. It is the same GUI used in the default debug flow. The steps to create, pre-arm, and run the startup trigger is just a set of 3 simple tickle commands. This feature is used to pre-arm the ILA core with the trigger conditions in a design so that the debug core is armed and ready to trigger immediately after device startup. This is accomplished by capturing the various trigger settings that are needed to be applied at device startup and by applying them to the ILA core in the implemented netlist. There is no need to re-implement the design. The time it takes to apply the trigger settings onto the implemented design and generate the bitstream is almost instantaneous. This slide details the Trigger at Startup flow. We typically start this flow by using Vivado to generate the bitstream with all the debug cores needed to debug the design, either inserted or instantiated into the design. Next, this design is programmed onto the relevant device using the Vivado Hardware Manager. Vivado Hardware Manager uses JTAG to communicate with the device. Now we start the Trigger at Startup flow. First, we set up the trigger conditions we are interested in that happen at device startup. We capture these trigger conditions into a Trigger at Startup file. Secondly, we'll apply these trigger conditions to the debug core by applying them to the implemented netlist. This netlist could be a result of opening the implemented checkpoint, or it could be the implemented netlist in the Vivado project flow. It takes almost no time to apply the trigger settings on the implemented design. Third, we write a new bitstream that contains the Trigger at Startup condition that was applied to the implemented design in the previous step. Now, this new bitstream is ready to be programmed into the device. This will pre-arm the ILA debug core with the Trigger at Startup conditions. If those conditions occur at startup, the debug core will capture the data, and this data can be displayed on the waveform of the Vivado runtime GUI. The important thing to note is that throughout this flow, we do not require the user to re-implement the design. I'll now demonstrate this flow in Vivado. We have a design where we are interested in triggering the ILA when the lock signal on the MMCM transitions from a 0 to a 1. Let's open the design in Vivado. I've already run this design through Vivado Synthesis, instantiated the debug cores, and implemented the design. I've also generated the bit stream. Let's open the implemented netlist. In this design, let's find the MMCM. Let's go to the Find dialog box using the Edit menu. We'll now find cells whose primitive type is MMCM, which is a type of a global clock. The find results indicate the design has a single MMCM. Let's open it in the schematic view. Note the lock signal output from the MMCM. The lock signal output from the MMCM is used to indicate when the MMCM has achieved phase and frequency alignment of the reference clock and feedback clock at the input pins. This event occurs within a predefined window, and we want to trigger on this specific event. In this design, I've instantiated a debug core that probes a set of relevant signals, including this MMCM lock signal. Now let's open the Vivado Hardware Manager. I'll now connect to a local KC705 board. Click on the green banner on the top and click on Auto Connect. This will automatically look for any local hardware target to connect to. Now select the device and right-click on it and select Program Device, which brings up the Program Device dialog box. It's already populated with the correct project bit file and LTX file. Click on Program. This takes a few seconds to complete. Now that the device has been programmed with the design, note the debug core in the design. Hardware ILA 1. This is the ILA core we are interested in. Note the ILA workspace that includes the basic trigger setup window. Now let's set up the appropriate trigger condition that we are interested in at startup. Let's drag and drop the lock signal to the basic trigger setup window. Change the compare value to trigger on the rising edge of the lock signal. The ILA will now trigger on the event when the lock signal transitions from a 0 to a 1. Also ensure the capture mode settings are correct. Here I've set the trigger position in the capture window to 50. This enables us to see 50 samples of data prior to the ILA trigger condition of the lock signal transitioning from a 0 to a 1. Now that we have set up the right ILA trigger conditions, let's save it to a file using the Run Hardware ILA Tickle command on the Tickle console. We save it to a file called ILA_trig.tas. Now we go back and open the previously implemented design in Vivado. There are a few ways of doing this depending on your flow. In a projectless flow, you can open your router checkpoint. In a project flow, you can use the Flow Navigator to open the implemented design. Since we are already in the project flow, we just use the Flow Navigator to transition to the implemented design. At the implemented design Tickle console, apply the trigger settings to the current netlist in memory. We do this by using the apply hardware ILA trigger command. We also give it the file from the previous step, which captured the appropriate trigger condition. Now, the third and last step is at the implemented design tickle console, write the bit stream with the trigger conditions using the write bit stream tickle command. Now let's go back to the hardware manager and reconfigure with the new bit stream generated in the previous step. Let's select the device in the hardware tree and click on Program Device option. Select the bit file that we generated in the previous step. Let's program the device with the new bit file. Now that it has been programmed, the new ILA core immediately arms at startup. Click on the Waveform Window tab. Notice the lock signal. At the 50th data sample, the lock signal has transitioned from a 0 to a 1. We've been successful in capturing the MMCM lock signal event that occurs at device startup. To summarize, you should now know what the trigger at startup feature is, how to use it to trigger on events around device startup. You have also seen the 3 quick steps needed to create, prearm, and run the trigger. You've also seen that once you program with the newer prearmed trigger at startup bit file, you can immediately view the waveform at startup and debug any suspected issues around startup. Again, the 3 steps required to do this are fairly quick, and there is no re-implementation required. Additional information on this topic can be found in UG 908, which is the Vivado Programming and Debug User Guide. Chapter 5 of the User Guide documents this trigger at startup feature. UG 835, which is the Vivado Tickle Command Reference Guide, also documents in detail all the tickle commands that were used to implement this trigger at startup feature. I hope you found this quick take video useful. If you'd like to get more information about Xilinx, follow us on Facebook, Twitter, or subscribe to our YouTube channel. Thank you.